Good morning. At 8 o'clock this morning, Voyager will be 1,700,000 miles. That's 2,700,000 kilometers from the cloud tops of Saturn, and it's closing in on the planet at 26,500 miles per hour, which works out to 11.9 kilometers a second. And that makes it still just under a billion miles from Earth, 965 million miles away. In the press conference this morning, one unusual nude set of pictures was put out, that having to do with the small moon Hyperion. The pictures available so far show that this is indeed a very irregular object. That in itself is fairly significant. And the way it looked in the pictures we have so far, it didn't seem to have its axis lined up right with its spin directions. But to talk about all of that and what this all may be and how it all may be disentangled, we hope, we have Joe Vaverka, a member of the imaging team. Joe, what about it? Is this an oddball object? First of all, it's awfully big to be so irregular. Isn't this a little unusual?
It certainly is an oddball object. I guess we don't know all the ways in which it's strange yet, but we're going to find out as we get a closer and closer look. I think it's true that the first views we got from Voyager 2 were rather surprising because, in fact, we were looking at the end which faces away from Saturn, and what we saw was a very rectangular cross-section. This is, I guess, the first picture we got. And the resolution here is something like 32 kilometers per line pair. And to the best of our estimates, the spin axis is in this direction.
Not lined up with the long axis.
And what we're probably looking at in this case is something that may have the shape of a chocolate bar. And you would normally expect that the long end of the chocolate bar would point at the planet, and that the flat end of it would lie in the orbital plane. This one came in at noon, yes. And
there's some change of aspect between the two.
Yes, we're essentially going around towards the trailing side. And as I said, we're about maybe 40 degrees away from the anti-Saturn point.
Good afternoon. At 2:30, the Voyager is a little over 900,000 miles away from the Saturn atmospheric surface and going about 28,500 miles an hour towards Saturn. All is working well. We have been watching recently, and we'll continue to see for a little while longer, some photopolarimetry of Saturn. Actually, what we're seeing are the backup photographs that go along with the photopolarimetry scans. These are going north to south across the surface of the planet, and we're looking for the information we get from the photopolarimeter instrument, quite a bit of which has to do with the nature of the particles, the size and characteristics of the particles that make up the high haze layers and the upper portions of the clouds.
The pictures Voyager 2 sent back this morning were part of a sequence of photos shot 10 hours apart. Scientists were hoping they would show motion on the planet. Such motion would help them measure wind velocities and help them understand more about various weather conditions on Saturn. First, some photos of a region in the northern hemisphere which shows up as a great brown spot. Voyager 2 took photos of it Sunday night and again this morning. The two sets of photos showed a great deal of motion in the spot. They found that the spot is what is called an anticyclone, meaning a high-pressure region which moves in a clockwise direction. Imaging scientists Andy Ingersoll and Gary Hunt were, in their words, delighted with what they saw of the great brown spot, calling it their most important discovery of this morning.
Oh, very nice. And not only have you got the flow around it, there's also something occurring right at the very edge.
Yeah. This is an intriguing image, all this
and
ribbed.
Notice also that we've got one of the points, which is almost a characteristic of anything that has a large flow. The internal part is generally sort of symmetric in its flow, but you always get the barrier, the points being set up at the edge.
Yeah, you can just see, without even getting a time sequence, you can see the rotation is this way.
More questions were raised about another phenomenon in the northern hemisphere region. This one, the ribbon-shaped configuration in the lower left-hand corner of this photo. Scientists are saying it is an eastward jet of wind blowing at about 300 miles an hour.
Now, there you are. There's a little spotty here, and there's the convection on the north side again.
Yeah.
Ingersoll and Hunt had wanted to find out whether the ribbon was causing the great spot or affecting it in some other way, but this morning's series of photos didn't answer that question. Voyager scientists like Ingersoll and Hunt will spend the next several months poring over these pictures, mapping and measuring the surface of Saturn, becoming even more familiar with its various features. But right now, they are like excited campers getting their first glimpses of snapshots they took on their summer vacation. From the interactive room in Mission Control, Bill Griffith, NASA NewsNet.
Down over the leading hemisphere, the hemisphere that faces forward as Iapetus goes around Saturn. But that's precisely what we're looking for. What can these pictures tell us about whether we have a superficial dark layer, or whether that's produced externally by stuff falling in, or whether it's somehow related to the activity itself. And particularly, we want to look at the individual craters and see how they relate to the light and dark.
The dark and light sides of Iapetus have nothing to do with the angle of light from the sun, but rather the intrinsic reflective surface of Iapetus. Morrison describes the difference in reflectivity of the dark and light areas as that of bright snow versus asphalt.
Leading theory to explain what happened on Iapetus is that the dark material came from elsewhere, namely from the outermost satellite of Saturn, Phoebe, and that it was chipped off of Phoebe in fine dust from impacts over billions of years, and this dust drifted inward, and Iapetus, on its leading side, as it went around the orbit, collected that dust. So it just painted the front of Iapetus dark, and the back stayed light.
Part of the light surface of Iapetus is splattered with craters. Part is quite smooth, as if an eruption of methane snow might have filled up the craters. The light side also has curious streaks that scientists had not seen before. Another new discovery in these pictures is a large crater with a dark floor, which may hold more clues to the ongoing geologic activity of Iapetus. The cameras of Voyager 2 have taken a series of photos of the satellite through different colored filters. These allow scientists to reconstruct a color picture of Iapetus and to get better information on the reflectivity of its surface. But still, they want to know more.
We are looking for a single explanation for almost everything, and that's because this is the first chance to look at it, and probably there is no single explanation, and there are different phenomena taking place. I'm focusing on what produces the dark stuff, and that may have nothing to do with what's producing some of the geological features that we're seeing.
Yeah, the thing we really need to constrain at are a lot of craters where we can see the floors if they're dark or if they're bright, then we just haven't been lucky enough to see it.
This is it. This is the highest resolution picture we're going to get of Iapetus in our lifetimes, probably.
Reporting from the interactive room at JPL, I'm Carol Ackright, NASA NewsNet.
Explain. And have now, after searching, then here, supposedly it would be located in some portion of this particular the dark gaps on the top and bottom of that close-up section.
In fact, it was within those two dark gaps that we conducted the search for this 30-kilometer object. Unfortunately, we didn't find one, and that leaves us unable at the moment, anyway, to explain the mechanism that creates these wide gaps. It was the only good theory we had at the time, and it's gone down the tubes now.
I hope another theory comes up.
And there's the outer edge of the A ring and the very narrow F ring that one can see very faintly.
One of its satellites apparently in the picture.
And Dione. Now, Dione is one of the satellites, icy satellites we visited very closely with Voyager 1, and actually we will not be looking at it as closely with Voyager 2. There are several, though, that we will be visiting more closely with Voyager 2, for instance, Enceladus and Tethys. Now, Iapetus also, we're seeing for the first time with resolution something on the order of 15 miles.
This is the one that has this curious marking. One side is many times brighter than the other. I heard that some material on the dark side is 10 times darker than that on the light side.
It's at roughly 10 to 1 brightness ratio. That's right. It's a remarkable object. This is Tethys. Tethys has a 500-mile-long canyon on it. We didn't image it very well on Voyager 1. With Voyager 2, we'll be able to resolve things as small as
now a little bit down at the bottom there.
One can begin to see the canyon right at the edge of the image. That's right. And there is Hyperion.
That's
a real
what we're
puzzle.
just beginning to see today, and discover that it doesn't look right at all.
It just doesn't look right at all. That's right.
Of course, right now we're still approaching closest approach. After we go by, we'll then see Saturn in the South Pole.
Yes, we'll be looking at the dark side of the rings, the side that's unilluminated, and we'll be looking at the south polar region of Saturn.